Well, you're welcome. This is Eddie's class, and there will be having some thought examples regarding uniform distribution. In the previous lecture, I gave you some theories or some theoretical perspectives uh, with regard to uniform distribution. So today, I'm going to give you some thought examples so as to familiarize yourself with it on how to work with the problem relating uniform distribution. Before going to examples, perhaps we remind ourselves on the definition that a uniform distributed random variable, which is continuous in nature, then its best function is of this form. Okay, it's f of x equal to k, which is defined within the two intervals theta1, theta2, and 0 otherwise. This is what we saw in the previous presentation. I think you will remember. So let us go into examples and see how to solve different problems regarding uniform distribution. Now we have question 1 says from our presentation, a subway train on a thin line ran every half an hour, midnight and 6 in the morning. What the probability that a man entering the station at random time during this period will have to wait at least 20 minutes. So you have to think on what is required to find from the question what have been given. The question says a train ran every half an hour. The first information is here. Every half an hour between midnight and 6 in the morning. Between midnight and 6 in the morning. Now, what is the probability that a man entering in the station at random time during this period will have to wait at least 20 minutes? So here are some keywords that will guide you in computing the required probability. So let's see. Now we have to let x to be our random variable, and our variable of interest from this is the waiting time, okay, in minutes. So waiting time being a random variable, and the assumption that is a random variable, then it should be for a uniform distribution, provided that the probability for that particular event to occur is the same throughout the given time limit. So we have also been told that the waiting time from the question, you can see, is every half an hour. So it is from 0 minute to 30, 0 to 30, 0 to 30. Okay, that is the waiting time. It is within 30 minutes. So this is the lower interval, that is theta 1, the up interval, which is theta 2 from the formula. So here the given information, we can go on and see how we can implement, how we can compute the required probability using the given information. Let's move on in the next slide. Yet is. So we start by recalling our formula. This is what we had in the previous presentation, the previous lecture. It is 1 over theta 1 and theta 2, which is equal to k, if you remember, in this interval, or 0 otherwise. This is the definition of our function. Now, what is needed then is to substitute the given values for theta 2 and theta 1 in this equation. And remember, theta 2 equal to 30, theta 1 equal to 0. So upon substitution, we have this 30 minus 0, 30 for theta 2, 0 for theta 1, and again 0 for theta 1, and 30 for theta 2. This is the interval, the range is within 30 minutes, and here it is 1 over 30 minus 0, which is the same as k in our previous lecture. So if you subtract here, we have 30. This is our function then, 1 over 30, which is defined between 0, let's equal to x, let's equal to 30, and 0 otherwise. So this is our general function regarding a given problem. Now, what's required then? What are we supposed to find from the question? Let's go back and see. This says, what is it? Here it is. What is the probability that a man entering the station at random will have to, during this time, to wait for at least 20 minutes? Now, you have to find the probability that a man entering in the station will have to wait at least for 20 minutes, meaning 20 minutes or more. So required it is to find the probability that waiting time is at least the keyword right here, because the one which will guide you in doing the computation. So this is what you have to find. P of x greater or equal to 8. Then what the formula? If you do remember, this is the continuous probability, and then you have to take the integral from the given limits, and then we have the results. So our function, this is our function f of x dx, integrating from theta1 to theta2. Then for 1 minus theta2 minus theta1, integral from theta1 to theta2, then the x. This is the function which I've just substituted, and what you have to find is p of x greater than 30. Remember, theta2 minus theta1 is 30, this one. So it's like writing f of x will be equal to 1 over theta2 minus theta1. Now, in substituting the lower limit and the upper limit, you have to go back to the question. What does the question needs you to do? Now, from this question, it says find the probability that waiting time is at least 20. Okay, so don't confuse this theta right here and this. Okay, so if waiting time is at least 20 minutes from 20 and above, now in integrating, our lower limit in the integration will be the given value, which is 20, that we need the probability from 20 and above. So in place of theta1, we substitute 20. You can see it is this one here. Okay, now it says from 20 and above. Now it moves up to how much? Our upper limit is 30, so it cannot go beyond 30. That's why it will be from 30, so from 20 to 30, which is our upper limit. Okay, our function is defined between 0 and 30. Otherwise, it is 0. So we need the probability that waiting time is at least 20. So it's somewhere here. Okay, before it should be before 30, but above 0. That's why we're taking integral from 20 to 30, then the x. Okay, so now this is the probability for x greater or equal to 30 will be equal to 1 over 30, which is the same as 2 minus theta1 from the function, then integral from 20, which is the lower limit, up to 30 dx. So if you integrate this equal to x from mathematics, will be equal to x. Okay. Now if you integrate x from 20 to 30, it's like, so we integrate the x, you get x. Now the limits are from 20, then up to 30. Okay, so taking the limits from 20 up to 30, now it's like taking 1 over 30, then 30 minus 20, because we substitute for x, we substitute 30. So it will be 1 over 30. If we substitute 30 to this one, then minus, we substitute 20 in x, it will be this value here. So 30 minus 20 equal to 10. So it's like taking 10, then you divide by 30. Okay? So 10 divided by 30 equal to 1 over 3, and this is the required probability. So in other words, we can say the probability that waiting time is at least 20 minutes will be equal to 1 over 3. In decimals, is equal to 0.33, something like that. So that is case number 1, and we have already our value, which is 1 over 3. Okay, so that's example 1, and I think it is clear. The most important thing to note from this example is we have theta 1, theta 2 solved minus theta 1, the first part here. This is the function. Okay, it will be a thing right here, this one. Again, we have this theta 1, the limit, the integrals, limits on the integrals. These limits, especially the lower limit and the upper limit, will depend on what kind of probability are you trying to look for, the intervals given. Now in our case, it's at least 20, that's why we took 20 right here up to 30. So if it could be other limits, for instance, put up the question there that the probability is between, let's say, 20 to 25. We could have done from 20, instead of 30 right here, we would have used, let's say, 25, the limit which have been given. Okay, so these limits changes depending on what have been given from the question, but this comes from the function right here. So don't confuse the limits, this one and this. Now I go to another question. So in the presentation, this was question 3. That's what I can see. This is question 3. Now what is saying? It says each day your newspaper arrives at a time that is uniform distributed between 7 a.m. and noon. These are the more information given. Then you find the probability that it will arrive during an odd numbered hour. Okay, it will arrive during an odd numbered hour. So a solution to this question, the time given is from 7 a.m. to 12 p.m. Okay, noon means 12 p.m. So substituting this information, this is the lower limit, theta 1, and this is theta 2, theta 1, this one is theta 2. So these are the intervals in which our function is defined between 7 a.m. up to 12 noon. So we substitute 12 for theta 2 and 7 for theta 1. We have our function, which is this. Okay, it is 1 over 5, 7 to 12. This is where our function is defined. Okay, at this point, and it is 0 otherwise. Now, as usual, as you can see, this question says we have to find the probability that the car, the train, it's a train there, or newspaper, yes, will arrive during an odd numbered hours. So as you can see, it's like discrete case, okay, but we can treat it as continuous because from 7 p.m. up to 8, it can arrive at any point of time. From 9 to 10, 11 to 12. Now these are odd numbered hours. 7, 8, then 8 is not odd numbered. 9 to 10 is odd numbered hour. 11 to 12 is also odd numbered hour. So we have to find out the probability that the newspapers arrive in these time intervals. Okay, 7 to 8, 9 to 10, 11 to 12. So we go back to our formula and we substitute the given values. Now this is the general case. Integral f of x equal to 1 over theta 2 minus theta 1. Remember, theta 2 equal to 12, theta 1 equal to how much? It is 7, yes, it is 7. integral of theta 2 dx. Then substituting for theta 2 and theta 1, you have 1 over 5. And if you see clearly, this 1 over 5 is the same as this one. Don't confuse others. Theta 1 to theta 2, theta 1 equal to 7, theta 2 equal to 12. This is general equation. Now, mind you, this 12 and 7 may be changing depending on what kind of probability we're trying to find. Okay? But this is general case. So, going back to our formula, we have to find the probability between 7 to 8, number 2, 9 to 10, number 3, 11 to 12. And here it is. So, the probability then, it is 1 over 5. This is the same as this one. 1 over 5. Then, number 1, it is between 7 to 8. So, we integrate from 7 to 8 dx. It is integral from 7 to 8 dx plus integral from 9 to 10 dx plus integral from 11 to 12 dx. Now, these are the three possible alternatives within our given range limit. All the numbered hours: 7 to 8, 9 to 10, 11 to 12. So this will, the summation of these will give us our required probability. And if you integrate, what comes in? Okay, this will be 1 over 5, and this will be x from 7 to 8 plus how much? Plus again x from how much? 9 to 10, again plus x from 11, is from 11 to 12. So this is 8. Yes, I think you can see clearly. Now this is my subtracting, so we take 1 over 5, 8 minus 7, which is this one. 10 minus 9, 10, we substitute x equal to 10, 9 is this. Then we substitute x equal to 12 minus 11, which is this. Okay, now 10 minus 7, so 8 minus 7, 10 minus 9, 12 minus 8, if you take the sum equal to 3. So to be 3 over 5, and here the answer, and this is the required probability. The probability that our event of interest, what is that? Let me see. The newspaper. The probability that the newspapers will arrive in odd numbered hours. It is 3 over 5. So hope that is clear. Those two examples are enough. And you have to go back to the lecture presentation and do, we have example 2. Here we have example 2. That is for you to make some practice. Okay, so let us finalize our lecture by trying to solve how to come up with the mean and the variance of beautiful division between the random variable. What we said is, this is the form of calculating the mean, and this is the form of calculating the variance. It is just 1 over 2, theta 2 plus theta 1, or 1 over 12, theta 2 plus theta 1 squared. So let's use example 1 just to illustrate on how to calculate these two parameters. Example 1, we are given theta 2 equal to 30, theta 1 equal to 0, okay, regarding the arrival of a passenger at the train. Now, if we need to calculate the mean, it means we simply substitute theta 2 equal to 30, theta 1 equal to 0 in this equation. And in case we are trying to look for variance, we simply substitute theta 2 equal to 30, theta 1 equal to 0 in this equation, and then we simplify. Here is the results. So, average waiting time will be equal to a half, 30 plus 0, which is 15 minutes. That is the mean. And the variance will be equal to 1 over 12, 30 plus 0 squared, which is 6.5 minutes. You are done. That's simple. Okay, having said so, we are done with the uniform distribution. Thank you for listening, and let's meet next time. I think we'll be discussing exponential distribution. Best of luck.